This is the review for Chapter 19, Confidence Rules for Proportions. And if you have the slides, you need to scroll down a little bit to get to the equation that's really going to come in use right here. In this instance, when we make a confidence interval for a proportion, we're going to take a sample proportion to try to make a confidence interval for the true proportion. And look at the statistics we're using right here. We have p hat, which is sample proportion. We have z star, which means we get to pick it. And then we have the standard error of p hat. The standard error of p hat is p hat times q hat over n square root. This is just like the last chapter, and the only difference here is we're using the sample statistics. This is because we don't know the true proportion. Imagine if you wanted to figure out what is the true proportion of students at UT who go out and party on Friday night. I'm pretty lame tonight, but go with me there. So you go out and talk to 100 people and you find out that 40 out of the 100 party. Well, you should be able to use those numbers I just said right there and figure out a confidence interval quickly like that. But let's review a little bit. There's assumptions we need to first cover here. We have the independence and randomization condition. Independence and randomization states that these need to be independently sampled, or they need to be independent of each other and randomly sampled. Once again, we have the 10% condition, always there, and we have the success failure. In this instance, though, it's slightly changed. Since we do not know p or q, we're going to use p hat and q hat. So this is the sample successes and the sample failures. That's what we need to look at here. In my previous example, I had 40 students who go out and party. That means 60 don't go out and party. So that's greater than 10 for both. That's how we check the success failure condition. If there's more than 10 successes and more than 10 failures. So with this in mind, we can make a confidence interval. One thing to talk about here is we get to pick z. And for the test, you'll be given these numbers, but they're not too hard to remember. We generally talk about 68, 95, 99.7. The 95 is generally 2, but many of you might know it's 1.96. That would be a 95% confidence interval. That's where that comes from. If you wanted to make a 68% confidence interval, which is something we usually wouldn't make, you'd put 1 in here. Think about a 99.7% confidence interval and what you'd put in there. You'd put in 3. So we can kind of understand how z works. As z gets bigger, the confidence interval gets bigger. 68, 95, 99.7. 1, 2, 3. This part of the equation after the plus or minus is the margin of error. You'll see this on every confidence interval. What I'm circling right now is the margin of error. The first part is the center, and it's always the sample statistic for what we're making the confidence interval for the population parameter. This chapter goes really in depth, but what you really need to know is how to make a confidence interval on your calculator. And to do that, you'll click Stat, Test, scroll over to the right and click Test, and click one prop z interval. One prop z interval. It'll be down a little bit on the screen. It'll ask you for x and n and the confidence level. X is the number of successes, n is the number of trials, and the confidence confidence level is just 0.95 if you want to make a 95% confidence interval. Go ahead and try doing my example from before with 40 people going out and drinking out of 100 to make a confidence interval for the true proportion of people who go out and drink on Friday night. This should set you up. Try doing more examples like this. Make sure you understand that this is categorical data. And we have here some other examples of what's going on. This is more relevant to doing the online homework, but this is how to do things for the test. Using the calculator is very important for the test, knowing how to do it. They talk about the margin of error. We scroll back a little bit. They have a little bit about confidence intervals. The statement, how we read confidence intervals, is, in this chapter, I'm 95% confident that the true proportion is contained within the interval blank to blank. Now make sure you give the context to it. I can't state that enough. Give the context. You'll see it on the test. What is the context? Make sure you give it. I haven't seen the test yet. I actually didn't open the email within it today. But if you see something that says give the context, give the context. So in the previous problem, I am 95% confident that the true proportion of students who go out and drink on Friday night, there's the context, is contained within the interval blank to blank. See if you can solve that. One last thing to notice here is that the confidence interval doesn't always have it. If you make a 95% confidence intervals, there's times where it's not contained in the interval, the true proportion. Well, that should sum up everything that is really important. Good luck.